Every digital system has vulnerabilities. Cars can be hacked, locked computers can be exploited, and credit cards can be spoofed. Security researchers make a career out of finding these types of vulnerabilities. Samy Kamkar's approach to security research is not just about dissection, it's also about creativity. For many of the technologies that Samy hacks on, he open sources code that summarily describes the vulnerability he has been working on. For example, in his project PoisonTap, Samy open sourced code that you can run on a $5 Raspberry Pi and plug into a locked computer to exploit it. Our conversation covered the art of deconstructing technologies for vulnerabilities and Samy's goals as a security researcher. We also touched on some of the broader issues of modern security. This was a fascinating episode, and I enjoyed it a lot because of Samy's ideas of creating an artifact around the exploits that he finds to engage his creative instincts as well as his security hacker instincts. Also, Software Engineering Daily is having its first meetup on January 11th at Galvanize in San Francisco. And if you're in the Bay Area, you should come check it out. There's more information on meetup.com if you can find the Software Engineering Daily group, or you can go to softwareengineeringdaily.com and click on the Meetup tab. I hope to see you there. Every software project uses email. Every time an e-commerce site processes a transaction or a user makes a comment on a social network, email notifications are sent. SparkPost provides email delivery services for apps and websites. To try SparkPost and send 100,000 emails a month for free, go to pages.sparkpost.com/sedaily. SparkPost has a range of pricing options, from free self-service packages to sophisticated enterprise support and services. Start sending emails to your users today. Go to pages.sparkpost.com/sedaily to send 100,000 emails a month for free. Thanks to SparkPost for being a new sponsor of Software Engineering Daily. And if you want to send 100,000 emails a month for free, go to pages.sparkpost.com/sedaily. Samy Kamkar is a security researcher who has worked on a variety of open source projects. Samy, welcome to Software Engineering Daily.
Awesome. Thanks for having me.
Your projects usually expose a vulnerability or some kind of hidden feature of hardware or software, and it's often through an insight that other people who have worked on the system did not have, or you're just looking at it from a different angle. What drives your curiosity to inspect systems for vulnerabilities rather than to create brand new software products?
Well, I would just argue that a little bit in that pretty much everything I do, whenever I release a project, it's actually really important to me to also create something. Definitely, most of it does focus on breaking things and exploiting things, but I really love creating things too. So pretty much every project I do is not necessarily just exploiting a vulnerability, but rather creating either a piece of software or hardware combination that does that interesting exploit. And I guess, to answer your question, why is it maybe mostly focused on that? I think it's just ever since I was a kid, being able to exploit something has been really interesting. I think I did basic puzzles as a kid, and that was always fun. And the idea of, really just hacking something, it always feels like you're solving a puzzle that wasn't meant to be solved. If it feels good to solve a puzzle, it also feels good to create stuff. But when you solve something that wasn't ever supposed to happen, or it's not supposed to be possible, I think that's even more exciting for me.
Well, it's a good point that your projects tend to have an artifact that comes out of the end of it, whether it's a piece of software or some kind of strange hardware device that's used to expose the vulnerability or the hack or whatever it is. Your projects are quite creative, and I'm not sure if many people listening are security researchers, but I know that there are a lot of people who are listening that work on side projects. Can you describe your ideation process for coming up with inventions and projects?
Sure. This is obviously software radio, so maybe we can go over some of the software stuff. I guess initially, I guess a lot of it's just curiosity and exploration. There's always so many cool new technologies that other people are creating. So a lot of it is me just trying to learn these new basic elements, or these new tools, or if a new, let's say HTML5 comes out, right? There's this suite of new features that can be used, and of course, new stuff is coming out in browsers these days all the time. So I'm kind of always interested in like what those things are. And I guess just as I dig in a new technology that I'm interested in, the issues sort of pop up. I'm not necessarily looking for an issue. I think often it's just kind of, I'm just exploring how something works, and then I might discover some problem, and I think, oh, that's really interesting. Maybe I can do something around that. I'll give you an example. There was, several years ago, I was looking at HTML5 had started coming out in browsers, and this is, I remember there was a geolocation API. I was like, oh, that's very cool. And I tried it out. I took some JavaScript code. It was only implemented in Firefox at the time. And I used some JavaScript from Firefox and implemented the API. And I went to the site, my own site that executed it, and it said, did I want to allow this website to essentially see my location? I was like, okay, allow. And it got my physical location down to the physical address, like very, very accurately. And I was extremely impressed because, hey, it's like 5 years ago. And Firefox was the only browser that had this functionality. And I had no idea how it worked because we don't have GPS in laptops, right? We only have GPS in mobile phones, for example. So after inspecting it further, I learned that the way the API works is that it actually sends all the MAC addresses of all the routers around you up to Google, and then Google will return coordinates back to you.
Wow.
So Google has this database, and I thought that's kind of interesting. So basically, Google knows where all these routers are, any wireless router is, even if it's encrypted, because the MAC address remains unencrypted. So I thought, typically, it asks you, the browser will ask you whether you want to share that information with the website or not. But most routers will actually expose the MAC address publicly through its web interface. So all you have to do is find a simple cross-site scripting vulnerability, which you can find in most modern routers, and then grab the router MAC address and then send it to Google yourself. So if you, let's say, visit my own page, I can grab your router's MAC address, send it to Google, and then get your exact coordinate. Without any authorization from you. So there's like
incredible
sort of cool things, and that was sort of spurred off of just being interested in how geolocation API worked.
Do you collaborate much with other researchers, or do you just work alone and you feel like you have more leverage working alone?
I definitely love collaborating with other people. Sometimes it's hard. Lately, I've been working on a lot of hardware stuff. But I definitely have a ton, I have some good friends that I've known for many, many years in sort of the security community and software community, that I sometimes work on projects with. Often the way it works is there will be other people who might actually build a really cool tool. And then I might use that tool for some projects, and then I'll build some projects on top of that tool or using it, and then I'll release some stuff, and then I'll contribute back to their project. They'll contribute to my project. So there's a lot of sort of sharing and melding going on, even if it wasn't, let's say, a direct collaboration on a specific project.
We did a show about car security a while ago, and you've done some research into this. I wanted to ask you about it. My understanding is that the vulnerabilities in cars often come from the entertainment center, which often has some leaky abstractions that can become dangerous. What worries you about car security? What got you interested in car security?
I think so. Charlie Miller and Chris Valsek, they pulled off the most amazing car hack ever, and that was maybe 1 or 2 years ago when they.
This was the Wired thing, right?
Correct. Yeah, they hacked the Jeep, an unmodified Jeep Cherokee, over the internet, and were able to essentially control brakes, transmission, the dash, all sorts of things. Absolutely incredible. And yeah, as you said, a lot of it comes from sort of the infotainment system. And that's because it's running a lot of, often those systems are running Windows or Linux, right? They're running full operating systems. They're running all sorts of, they have to support all types of different codecs and, video codecs and music codecs. Though those by themselves are often full of vulnerabilities. We usually see some pretty good ones there. You just have a ton of software there. So there's just a lot of, the attack surface is really wide. additionally, it has a lot of ways to communicate with the world, right? You have Bluetooth to communicate with your phone. You have the radio, which radio has, their radio protocols. Other than FM and AM, you also have like RDS, which actually reads data from radio transmission. That reads digital data. You have, the CD-ROMs will offer, the CD players will often be able to read firmware from CDs. You have the rolling code system from the key fobs, which are wireless. So there's just a lot of sort of communication points. Nowadays, most cars also have GSM, right? They have some sort of like OnStar capability or other mobile capability that allows them to be connected to the internet.
Mm. And you've also done some research into drones recently. How does the security model for cars compare to drones? And do you think that the ideal security model for a car looks similar to the ideal security model for a drone?
That's a good question. I haven't thought about that. Drones and cars are not very similar. I have seen some drones where they will use the CAN bus protocol, which is also used in cars. But other than that, I mean, most drones don't have very much security. I guess you could say that for many areas of vehicles as well, although vehicles are improving all the time, so that's good. I don't know. I guess they're kind of different beasts.
Sure, like very different applications, I guess.
Yeah, but they definitely, they're still both running OSs. You still probably have Linux on both of them. So I think the protocols and often the communication. So, typically you're controlling drone via some RF communication protocol. Sometimes there are multiple RF communication protocols. Often there's like some proprietary control for controlling the drone. There's an additional link for telemetry. And you might be able to send sort of autonomous commands or go to, these GPS positions. Drones will use GPS to detect where they are. So that, unfortunately can be easily spoofed. There's no security, authentication, or encryption with GPS. So that can be spoofed with sort of open source software and hardware pretty trivially. And then cars, yeah, they sort of, they don't have that RF link for control. That's all sort of manually controlled until you get into features like Park Assist. And Park Assist means the computer, the ECU in the car can actually control the steering wheel and the brakes. And it's that same ECU that's connected to the infotainment system, which is also connected to a mobile phone, which is connected to the internet. And that's how you can essentially jump from system to system until you can control, the wheel.
Yeah. So getting to some of the projects you've done more recently, there's a project called MagSpoof that you did to spoof credit cards or magnetic stripes. And credit cards, they seem quite vulnerable, and we see this in MagSpoof as well as this epidemic of skimming machines where you see somebody put a big credit card machine on top of a normal ATM or credit card machine and just skim the credit card information off of that. What insights into the credit card security industry did the MagSpoof project give you?
Yeah, that was a fun one. I've never messed with magnetic stripes before, so I really didn't understand them or know what they did. And I wasn't even sure if they really were magnetic. I just always called them mag stripes. And here in the U.S., I don't know why we've only recently started to move to chip. And honestly, I think it's probably because of the Target breach. I believe Europe and many other countries have been using chip and pin for the longest time, and only recently have they introduced chip here, and they didn't even introduce pin, which is kind of just doesn't make sense to me. But I guess the things I learned from developing MagSpoof was first I want to see I want to understand how mag stripes worked, and I learned yes, they absolutely are magnetic. So you're essentially having binary data on that mag stripe. And I thought, okay, well, if it's actually magnetic, couldn't I use an electromagnetic field to emulate a credit card? So even on a typical MagStripe reader, something that doesn't necessarily support NFC or RFID. So I sort of wound a coil and then hooked it up to a motor driver and an AT-Tiny microcontroller. And I was able to essentially emulate my credit card just by turning that motor controller and pumping current through the coil. And I could go up to any MagStripe reader and perform a purchase by emulating my credit card. So then I was curious about what the data was. And there was things like your PAN, which is your credit card number, the expiration. There's a different type of CVV. It's not the one written on your card. It's a different CVV that's also in the mag stripe. And there was some other information like something called a service code. And what was really interesting about the service code is the service code tells things like whether you're allowed to pull cash out of an ATM, whether the card's allowed to work internationally, and whether the card has chip or not, and chip and PIN or not. And I have a couple of credit cards, and I was looking at my chip card, and that said, the service code said it has chip. So I went to Target, and then I swiped my card that had chip in it, just a regular credit card, and it said it wouldn't allow the swipe. It said you have to insert the chip because it knows there's a chip. And I was like, oh, that's interesting. So then I inserted the chip and everything worked. I was like, I wonder if I could what happens if I flip that bit? So I took my MagSpoof and then I took the entire, Amex credit card and information off the mag stripe, except I flipped that one bit. And of course I fixed parity so everything, error correction would work. And I went back to Target and then I used my MagSpoof device to send that credit card, and lo and behold, it worked. It didn't require the chip. So there was virtually no security in that service code. It was just, you're basically saying, oh yeah, are you legit? And you just say, yeah, I am totally legit.
When I'm choosing the tools for my side projects, the first thing that I look for is ease of use. That's why I love MongoDB. It is the most popular non-relational database, and it is super easy to use. At the beginning of a project, I often don't know the shape of my objects, and Mongo makes it easy to evolve the database schema as I like over time. Over time, as my project gets popular, I'm going to need to scale, and thankfully, MongoDB has built-in horizontal scalability. But configuration and database maintenance aren't really what I want to spend my time on. Thankfully, MongoDB Atlas was released in 2016. MongoDB Atlas is the easiest way to get access to MongoDB without having to run the database yourself. You pay only for what you use, from small projects all the way up to large production deployments. To try MongoDB Atlas today, go to mongodb.com/sedaily and get a free $25 in credit. Use promo code GOATLAS25 to get that $25 in free credit. Atlas is the only hosted MongoDB service built by the engineers behind the database, the company MongoDB. With Atlas, you get end-to-end encryption, you get VPC peering, you get access to the latest releases, and for a limited time, you can go to mongodb.com/sedaily, enter promo code GOATLAS25, and get that $25 in credit and get started with MongoDB Atlas. Thanks to MongoDB for being a new sponsor of Software Engineering Daily, and thanks for being the database behind a lot of my favorite side projects in the past. We're really happy to have MongoDB as a new sponsor of Software Engineering Daily. Now we've talked through some of your projects. I want to zoom out a little bit, and I'm not sure how much perspective you'll have on this, but there was this Mirai Botnet a few months ago that took down Netflix and Twitter and these other sites, and this to me feels like a big deal. It feels like a big deal, but it also feels like a precursor to more chaos more than anything. I think there's been some talk like this, if you look at the volume of bots on the botnet versus how much damage was actually done, there could have been a lot more damage. Have you looked at this in detail? Do you have any perspective on how bad this type of attack could get?
Oh yeah, it can get. It's going to get awful. I think you're right. If you looked at Mirai, I'm not sure if I'm pronouncing it right, but all it did was it used default credentials for IoT devices. Mostly IP cameras. That's all it did. It literally scans the internet, looks for devices that have SSH running, and attempts and brute forces with default credentials across several, manufacturers of IoT devices and IP cameras. And if it works, if it logs in, then it installs itself and then continues. That's all it did. I mean, there was and that's going to continue to happen as we continue to, as more and more IoT devices get released, and many of them have SSH enabled by default and have default credentials. I mean, if we really if we just got rid of default credentials, this wouldn't be a problem. So it's definitely going to continue. It wasn't sort of it wasn't a crazy sophisticated, thing like Stuxnet. With 0 day after 0 day after 0 day in order for it to traverse, so many computers and flash drives and everything else. So someone who wants to can make it even better. They can add more devices to the source code. The source code was released. Granted, it's not too difficult to write a, SSH brute forcing tool. You just need to go and sort of find what are the most common devices out there running SSH and then start scanning.
The attack vector, or the attack surface, I guess, for Mirai was a DNS provider. They decided to go after a Dyn DNS.
Right.
Are there other major weak points of internet infrastructure that would have this cascading failure effect that we saw with Dyn?
I think definitely DNS. Whether it's a major DNS provider or whether it's root DNS servers, although you need to hit a lot of them. And then I think the next, the next place would be CDNs. So just content delivery networks that are hosting a ton of the content for a lot of these major websites, be it whether it's Netflix or Twitter or whomever.
So we're talking about AWS or Cloudflare or whatever CDN.
Yeah, exactly.
So it sounds like you are not sure whether these types of services are adequately resourced to provide enough scale up in this type of event. Do you think they might be, or?
That's a good question. I mean, I guess it just depends on the type of attack, especially if you can, if you can get something, if you have legitimate machines that are making legitimate requests, it makes it, and you can randomize those requests enough, then it also makes it difficult to stop because you don't know where to route. You don't know what's legitimate and what's not. Where, if all the traffic looks the same and that's part of the DDoS, then you can at least put in filters and rules that would help stop some of that traffic before it hits, whatever edge servers. So I'd say I'm sure many of them are prepared and many of them are not. And the question is, how big is it going to get? Right. That's I think another concern.
Yeah, it sure is. I mean, Bruce Schneier was in front of Congress talking about this and advocating for government intervention because the market can't solve this. I think he was talking more about the default credentials stuff, but the default credentials is just like the low-hanging fruit. Do you agree that this is something that the free market forces can't really correct for?
I just look at it and I say it's not a difficult problem to solve. It's don't use default credentials, and you can't. Here's the thing: you can't assume that users are going to put things on the internet, whether they're told to or not to. They're going to do it because it's convenient. Like if you have an IP camera, it's convenient to be able to go home or go to your office and then see what's going on the IP camera at home. And if you're not using one that's cloud-based or that's handling, if you don't know anything about networking or you don't care, you're probably just going to put it on your DMZ or port forward or something. And now it's on the internet. And now you haven't, if that has some default credentials or a default SSH key or an insecure web server or whatever, then it's going to be exposed to attackers. And I think manufacturers just have to assume that. They just have to, you can't just put in a manual, don't put this on public IP. You just have to assume they're going to. So really don't do default credentials. That's it's kind of the very basic next step to solve a problem that we've known about for a long time. Yeah,
I mean, I agree with that. What was interesting, I think I was listening to Security Now, and they were reporting on this, and they were talking about the response from this. I think it's one very specific Chinese company that makes all of these cameras that have these default login credentials, and their response was kind of deny and put their head in the sand. And I wonder if it was because that getting your camera hacked by Mirai doesn't actually render your camera useless. It just turns your camera into a DOS bot. But I mean, I think you're right. Like,
I mean, to the user, I think you're right. To the user, they probably won't notice anything except some slow internet. But the user also doesn't necessarily know whether they're exfiltrating that actual video feed, right? Where's that video feed of? And not only that, you now have access to the internal LAN. So if I can SSH into a machine, and I say, so what if it's an IP camera on your network, because it was DMZ'd? Well, that means I can now jump off from there, and I can ARP spoof other machines on your network. I can DNS spoof everything. That means I can start modifying, intercepting, sniffing your traffic. So from there, that could be really dangerous. And the thing is, we're not going to hear about those sorts of things, right? You usually hear about that when it becomes, okay, this database from this big company was leaked, and no one really knows how that happened, but it was because someone was able to get into a single machine on that network. And then once you're sort of inside of a network, it's very easy to escalate privilege.
My sense is that in the past, your work and your intentions have been misunderstood by the government. And I'm wondering what your perspective is on the technical attitude of the United States government these days.
I think it's improving a lot. The cool thing is I actually do see government agencies sort of reaching out and going more towards security researchers who might not have the formal education or the formal haircut or clothes or look that they're sort of used to. And the way, if you've ever gone to maybe a hacker conference or something like DEF CON, you just have such an abundance of different types of people and sort of from different areas of lives. So I think they've been really closed off before to those sorts of hackers and security researchers, and more are embracing them because I think you'll find a lot of incredible talent out there.
Yeah, absolutely. And I know I've done some research into the United States Digital Service, which is very different from intelligence agencies or anything, but it's a very diverse crowd of people, and I think they let them wear T-shirts and stuff. So,
nice.
So you get a variety of types of people. But do you have any perspective on how secure our voting systems are? Because this has been quite a relevant security discussion recently.
Yeah, that's a good question. I personally don't know how secure they are. I would probably defer to was it Alex Halderman, who has done some really cool demonstrations of. He demonstrated hacking an e-voting machine several years ago, and I think he also wrote about the topic recently.
Okay, I'll check him out.
He's sort of, I think he would be sort of the number one expert in that area.
Okay, sure. So your work has exposed some surreptitious data collection by Apple and Google and Hulu and these other big companies. This was, I think, your work in looking at mobile devices mainly. What's your personal stance on these massive volumes of tracking data? Were you just trying to, did you not have any personal stance and you were just trying to expose it and publicize it, or do you have a stance on the tracking data assemblage?
I think tracking, taking information is okay. I'm actually pretty content with people doing that. I think there's some really cool uses for it. Just like I get Google Maps live traffic view because of all the crowdsourced information from all the phones that are, currently traveling on that road that I'm driving on or want to drive on. So I'm typically okay with it. What I'm not okay with is the lack of transparency or outright deceit. I think the primary thing that I exposed, although I demonstrated how all of our mobile phones are sort of our iPhone, Android, and Microsoft Windows phones were all essentially tracking GPS and Wi-Fi location and correlating that with signal strength and being able to do crazy triangulation. And then I could tap into all of those databases and sort of use it against people if I wanted. I'd say the big issue was users weren't ever sort of told that. And more importantly, if a user would go into their, at least specifically on their iPhone or Windows phone, and they would turn off location services or GPS, the phone would continue to track location information about them. So essentially, it would be disabled for all of their apps, like their Maps or Yelp or food ordering app. But the actual companies continued to collect that information. When at that point, you're actually lying to the consumer. I think if you disable that feature, then it should be disabled and it should not be used at all. But other than that, I think if you enable it and you want, I think you're providing some data and you get some really cool uses back. I think that's totally fine.
Tangential to that, I've been trying to do some shows recently about security and the relationship between privacy and related to WikiLeaks. And so Julian Assange came out with this book called When Google Met WikiLeaks fairly recently, and in it he suggests that Google has become tightly coupled with the U.S. government in terms of how much intelligence it provides. He describes Eric Schmidt as somebody who just moves fluidly between Google and the U.S. government. I don't know. We all have our opinions about Julian Assange, but how much truth is there to this? Does this worry you, like how cozy the government has gotten with large corporations?
This is something that I just don't know what to think about it, because I just don't know, right? I don't know what it's like to be in one of those big companies, especially, at the top and dealing with those sorts of orders. I don't know what it's like to be in the government. I don't really know what, I think I'll say this. I'll say I used to want a lot more, say, privacy, personal privacy, and I wanted sort of no one to ever know what's happening with my stuff and my data, and I guess I still do. I still don't want anyone to. Although at some point in my life, I kind of changed and said, well, I'm not. If I trust certain people, then I'm okay with that. But it's also a slippery slope, and I guess I just don't know, like, what has, let's say, the U.S. government been able to, what have they been able to do with their previous PRISM and other sort of tracking programs? Like, what were they able to do, and not what were they capable of doing, but what have they done? And they're never going to share that, because they'll essentially reveal, have they stopped terrorists? Have they stopped attacks? I assume they've stopped some things, right? They're not doing it for nothing. So I think it's like they have their heart in the right place, and they also were probably doing active things. I just don't know, and I don't really have that information. So I try to think, I think about it a lot, but I don't think I've thought broadly enough about it to really have a strong opinion anymore, when I actually used to have a stronger opinion. And now I do think people should. I do love sharing information. I think anyone should be able to access sort of information out there. So I definitely am always sharing, sort of, if people care and they want to encrypt their data. I always share how and ways to sort of keep yourself safe online, offline, keep your data safe, what to trust, what not to trust, and
yeah, I respect that response, the measured, tempered response of not really knowing. I think there has been an unfortunate narrative that when we have this massive data collection and this quote-unquote surveillance, we get something that asymptotes towards 1984. And I think some people still feel that way very strongly, still believe it very strongly, even when there is a lot of evidence to the contrary, that these devices and all these technologies give us incredible freedom, incredible creativity. Of course, there are the downside risks of 1984 type chilling effects or whatever kind of arguments you want to make, but I think it's very uncharted territory, and you can't even look to like a futurist novel by George Orwell for guidance.
I don't know. I do feel it's a double-edged sword, and I just don't know which edge I like more.
Sure.
I know which edge I personally like more, but then I think, well, I trust myself. I don't know if I trust everyone else, and it's a tough question. I wish I had a better understanding or idea myself.
Most of the people who come on this show work for some kind of company. You are an independent researcher. Why did you choose that route as a career rather than joining a larger company or starting a larger company where you could do more delegation, perhaps some larger projects? What? Give me a sense of that.
Sure. When I was younger, I started a voice over IP company many years ago, I think when I was 17 or so, and I did that for some years. And at some point, the company grew and it was awesome, like an amazing experience. And then at some point, I just wanted to I wanted to leave. I wanted to travel. I wanted to do other things. And it took me a while to be able to sort of move my responsibilities, or I guess I just didn't delegate properly from the beginning, to the point that I could leave and go and do things while the company sort of continued to, support customers and build stuff. And then after that, I think through traveling, I was just started researching different areas, and I've just really liked the ability to kind of any day, any time, just kind of look at whatever I wanted, whatever I was kind of interested in, because I definitely get into I'll get into like a week where I'm just super interested and super focused on something, and if there was something else in my way, that would suck. So I guess the lifestyle just became really attractive.
What kinds of security precautions do you take personally?
I don't think I'm as paranoid as I should be. I would say I do encrypt. I do encrypt as much. Most things. I encrypt my hard drive. Let's see. I sort of ensure I'm always using SSL when visiting websites. Well, TLS. I don't know. Those are the main things. I guess I have some apps running. Like I'm on Mac OS, and I have something called BlockBlock, which tells me if something is trying to install something into startup. Little Snitch to tell me if an application is trying to make an outbound request to a port that it's not used to. I jailbreak my devices and play around, do a lot on there. And
it sounds like those precautions don't have they don't infringe on your ways of living life and make it any different than somebody who does not have an intimate view of computer security.
I mean, I think you want to have some knowledge of technology or your computer when you're using some of these tools. Some of them you don't have to, right? If you use FileVault or BitLocker I'm sorry, not FileVault, it's Veracrypt now. Or I'm sorry, yeah, you can use FileVault on Mac OS. If you're using that to encrypt your hard drive, you don't need to know anything except your password. You don't need to understand how FileVault works. So I think that's kind of cool. Some of the things that you kind of do want to understand what it's doing, like, do you want to allow this weird kernel extension that you've never heard of, db.kx to install onto startup? Well, maybe that's your Dropbox kernel extension. Maybe I can realize that, but someone else might not. But yeah, I think if people are interested, they should definitely explore and just try some of these things out, and they can always remove them later, of course.
You mentioned Stuxnet earlier. Have you looked at Stuxnet in depth?
Not crazy in depth.
Okay.
Have you?
I saw a movie on it that was good.
Oh, cool.
It was called, I think, 0 Days.
0 Days, okay.
Yeah, and it like you said, Stuxnet took this crazy orchestration of 3 0-day attacks to have it work.
Yeah.
It's quite an amazing project. I didn't totally agree. So the film kind of takes this narrative that Stuxnet kicked off this new level of cyber warfare because it sowed the seeds of this type of cyber attack that you could have. But I didn't totally buy it because it seemed like there's a lot of expense that you have to put into making a worm that's that sophisticated. It's not like once you write it, it's like write once, run on any type of attack if you want to.
I would feel that nation states who work on this sort of stuff are probably getting close to that, if not already, because if you look at a lot of the viruses that come out, so with Stuxnet, they found that there were a lot of similarities to another virus called Flame. Right. So they found a lot of similar binary functions that were probably the same thing. So that means that it's likely, at least if I were building something like this, I would make it modular. Right. I'd have various modules, and they would all sort of perform various functions. And when one was, 1 0 day was caught, well, you just create a new package with the next 0 day that you have. And of course, many nation states have employees who are just doing that. They're just looking for, they're just combing source code and just fuzzing binaries to find new exploits. That's all they do. So who knows how many they actually have.
Does this kind of stuff spook you out at all? Like, do you have a feeling like we're inching closer to some sort of global cyber war or other kind of inevitable catastrophe?
I'm definitely, I mean, while it could cause a catastrophe, I'm totally fascinated by it. I think it's like exciting. It's like, it might be a car crash that you can't look away from, or it's like a fire, right? It might not be great, but I love looking at it. I think it's really interesting. I'm fascinated with the technical part, and yes, to see something like Stuxnet, that is incredible.
How do you hold those two ideas in your head at once? The idea that this could cause some kind of catastrophe, and the idea that it's very fascinating.
I guess it's like I don't know who said it, but when it comes to, say, freedom of speech, I maybe you can tell me who said it, but it's like something like, I don't support what you say, but I uphold your right to say it. It's kind of like that freedom of information. I feel like it's information that will get us in a ton of trouble by like actually sharing information, sharing schematics. Like, I don't necessarily want guns in my house, but I think people should be able to share 3D models of guns. I don't think that should be illegal. Whether owning it, then I don't know. I don't know about that. I haven't thought about it. But I want the information to be available. I also believe that information is going to be, ultimately, I think information will ultimately be our downfall in one way or another. But I don't think we should restrict information because of that.
Can you elaborate on that? What do you mean information will be our downfall?
I mean, it's you have scientists who can create an atomic bomb, right? That's just information and scientists working towards and working together and sharing information that gets you to that level. If you forbid people from learning science, then you won't ever have an atomic bomb. Does that mean you should stop people from learning science or studying science or researching? I don't think so.
Software Engineering Daily has 20,000 engineers listening Monday through Friday. If you are hiring, or if you have a product that you would like to get into the hands of engineers, send me an email, jeff@softwareengineeringdaily.com. This podcast is sustained by the advertisers, and if you would like to become one, or even if you're just curious and you want to learn more, send me an email, jeff@softwareengineeringdaily.com. Thanks for listening. But do you take any precautions? Like the Mirai Botnet like really spooked me out, and I was like, I don't know, maybe I should keep some cash under the mattress or start putting money in Bitcoin and gold. And I mean, as somebody who's kept a close eye on the security world for such a long time, do you take any like tail risk precautions?
I guess sure. I do think you should keep some money, under your mattress. But the good thing is, if the internet is destroyed or something terrible happens, we're all in it together. So we're all going to be on the same level, right? It's not going to be like a bunch of people have Bitcoin and they are able to do everything and no one else is, right? I do think Bitcoin and Ethereum are interesting. So, I would also probably say, yeah, you might want to get some of that too. But I'm not, we all sort of have the same dependencies, right? We depend on the same thing. We, especially if you work in technology, if whatever happens, it sort of will happen to all of us. So I think as long as we're all together, I think that's okay. I'm not too worried then.
So of all the systems that I've read about you attacking, I guess I was going to ask you, like, are there any vulnerabilities of social networks that you'd like to inspect? But I just remembered that the very first thing that you ever attacked was MySpace.
Yeah. So I stopped. Yeah, I stopped after that.
You stopped with that, okay?
Yeah. I got raided by the Secret Service. I couldn't touch a computer for 3 years, and then I was like, all right, let's not look at social networks.
Hypothetically, is there anything you would do if you were poking at Facebook?
Well, they do have a vulnerability. They do have a bug bounty program, so that's
true.
That's really cool that they do that. What would I look at? I guess I would kind of.
What fascinates you about Facebook?
I mean, I think it's a really cool tool. I think it does a ton for a lot of people, and I guess those are the two different questions. If I were looking for vulnerabilities, then I'd be looking at sort of their latest features. That's probably the first thing I'd be looking at, because I think you're going to have less people looking there and more likely to find a vulnerability in a new system than an old one. But I don't know. I like Facebook. I use their events system a lot. So I mean, they have a ton of systems now, right? They have a ton of stuff going on. So I don't know a tenth of it or percent of it.
So there was a quote. Bruce Schneier was on the show a while ago, and one quote that he said that stood out to me was, we are finding more and more that security is less about what you did think of and more about what you didn't think of. What are the areas of security that you think are underexplored or that we're not thinking about as much?
I think it's like physics. I think it's physics-based attacks. So I'm talking side-channel attacks. I'm talking emanations that leak from your devices. For example, I think it was the University of Tel Aviv. They demonstrated a couple of really cool attacks where, in one attack, they were able to take an Android device, an Android phone, set it next to a computer, next to a laptop. On the laptop, they typed an email and then encrypted it via PGP. Based off the PGP encryption operations, the capacitors and resistors around the processor, around the CPU and the laptop, produced ultrasound that humans can't hear, but the microphone of an Android device could, or really of any phone, could listen to. And it recorded that, and they're able to take that data and then convert those unique sounds into operations. Because essentially, while you're encrypting in software, depending on each bit of your key, you're going to perform a different operation. Or it will take a different amount of time. So based off that, they were able to extract the PGP key used to encrypt that email, literally from a device sitting, on the desk, which it wouldn't be unreasonable for someone to set their phone on somebody else's desk while they're, meeting or leave it there. So that would be one example. I think RF emanations are really interesting. So basically radio frequency and electromagnetism. Ever since the Tempest attack, when CRT monitors gave off radio emanations that could be essentially listened to from another room and converted back into a screen, into a monitor, so you could see what the user was seeing in the other room.
What is the Tempest attack?
Tempest, TEMPEST.
Ah.
And it's basically your CRT monitor. We no longer use CRT, but a CRT monitor would give so much RF emanations off that you could pick it up with an antenna a room away, and then you could convert that data back to a visual, basically to a screen, to what they're seeing on their monitor.
Incredible. Did that happen as as an actual hack in the real world, or was that just a researcher that discovered that?
I think it was the NSA, but I'd have to double check.
Wow. Interesting. So when you're talking about these physics-based attacks, what kinds of ideas is this giving you? Like, are there any specific areas that you're thinking about diving into, experiments you're thinking about running?
I am working on one project that is in the RF area, but I won't disclose too much until I get it working, or hopefully, I get it working. I think it'll be really cool. But it's basically, just a wireless related attack that's sort of new because it's not really exploiting any real vulnerability in software or hardware. It's more just exploiting physics in the way that we've constructed things and the way things work. So I'm excited about that.
Now, do you think that is underrated as a concept of like practical application, or is that mainly like do you think if more people were thinking about this, there would be more practical applications, or do you think this is more of something where it's just strictly going to be a vulnerability?
Practical applications. I mean, I think. I
guess if you wanted to convey information from point A to point B, you'd much rather use Bluetooth or just over Wi-Fi or something rather than using some sort of complex physics procedure.
I don't think you'd want to use this unless your goal is to essentially be performing steganography, where you're trying to hide the fact that you're transmitting information, so you make it appear like it's leaky, electromagnetism from unintentional emanations. So, I guess it depends. Practical, I think it depends who you ask. I think if you ask the NSA, yeah, they have practical reasons for doing this sort of thing. Other nation states, absolutely. I think it'll be practical to understand these things so that we can also protect against it, because people will start using these, and I suspect people already are. I suspect nation states already are. It's just that we don't know about it. So I'm definitely interested on what are the things that are happening that we don't know about, or what are the things that will happen that we can discover. Like those are the things that are super interesting to me.
Is this the first project you've been working on since PoisonTap?
Yeah, I would say that's probably it. I'm probably working on one or two other projects. I'm always kind of working on a couple of projects. It's just I usually don't get most of them done. So only 1 out of 10 ever makes it to the finish line.
How do you manage those? Because I think that's actually something that's a trait that's shared by a lot of programmers, where they start a bazillion projects and then they rarely finish a project, or in the worst case, never finish a side project. I know a lot of people who have started side projects and they just don't know how to will themselves to finish a side project. Do you have any recommendations for how to think about that?
That's tough. I mean, that's something I struggle with myself, because I wish I would see certain projects through, and I just often lose motivation. I lose interest in a lot of things, and I'll move on to something else. I would say, if I had any piece of advice to try to share, then I would say, okay, if you get bored of it, that's okay, but at least move on to something else, another project where you're learning, because I often find that after I'm learning about some, let's say, I'm working on one project A and I get bored, or I hit a wall and I don't know how to move forward, or I'm not really interested in moving forward because it's not fun anymore, then I move on to project B. Instead of, I guess I have the option of turning on Netflix or going to project B. If I often turn on Netflix, but some days I'll go to project B and I'll work on that for a while, and then I'll learn a bunch of stuff, and then I'll probably get bored again. But at some point during project B, or maybe even project C, I'll have learned something that will give me a really cool idea for project A, and then I'll return to project A and then continue working on it and get like a new boost of motivation on that, and I might be able to finish project A at that point. So I'd say that happens to me a lot. I'll be working on something and I'll hit a wall, and then I'll just move on to something else, and that will spur some ideas in my original project that, I don't know, I might not have had as much fun just sort of hammering through.
When you hit a wall, is it more that you just have like so many tasks in front of you that you don't want to do it, or do you hit like you can't find the right piece of documentation, or what is it that will make you hit an impediment that you can't move beyond?
Yeah, I'd say a lot of it is I just don't have maybe all the information, or what I'm looking at is, it means I'm going to have to, I was looking at Bluetooth recently, and the spec for like Bluetooth 4.2 is just it's like thousands of pages. I'm just like, oh no, I don't want to read this right now. And obviously I don't need to read all of it, but to get I really want to understand it, and to really want to understand something, I should read the whole thing. Plus, not only read it, but then test implementations and see are implementations actually implemented the way that the spec talks about it. Were pages skipped? Were certain nodes skipped? What implementations are lacking what? And then potentially how can I use that to my advantage?
So when you do something like that, when you go deep on reading the Bluetooth spec or reading the HTML5 documentation, are you exceptionally good at retaining the information, or does it just like occasionally there's something that's like you find hilarious or interesting or crazy, and that it ends up being retained because it's so wacky?
Usually I can only retain information if I have something to apply it to. Otherwise it just goes, it goes in and out. So if I'm working on a project in that area, then I can usually retain it. Usually I do have to like create something. I have to create, I don't know, a demo app or a piece of hardware, and then I'll retain it really, really well. But until I do that, usually it's I guess I have to be pretty interested. Often I will try to read about something that I'm not crazy interested in, or like I'm a little bit interested, but I really haven't sat down and started working on anything in that area, and it might take me a couple times of reading it. I do feel like I kind of learn slower, and I do have to read things multiple times to get them. And another reason I also hit walls a lot is because a lot of the stuff I'm doing is not necessarily documented. Often I'm looking at binary or hardware that is proprietary, or protocol that's entire, RF protocol that's proprietary. There is zero documentation. Maybe there's firmware that I can dump off a chip or, extract from an encrypted download, sort of firmware upgrader. But that's all I have, right? It's just sort of reverse engineering, and that just takes time. Sometimes you find stuff really quickly, and sometimes it's just a hassle. It's just a ton of stuff to look through to get a better understanding of. If I don't have a good understanding of the underlying architecture or what's really happening under the hood, it takes me a lot longer to sort of figure that out. And sometimes that's my wall a lot of the times.
So it's you run up against some kind of reverse engineering problem, and you just decide this is going to take a lot of mental pain to get through.
Yeah. Sometimes it's just like a lot of sort of mental mapping, and there's probably better ways of doing it, and I just don't know how. Where I'm looking at just a ton of functions, and I just don't know what any of them do, and it's on some new architecture, and it's just I have to learn some new assembly instructions, and I have to sort of, because there's so much data to go through at the actual say looking at machine code. I don't even know where to start. I don't know where to begin, and I start documenting things, and I try you learn pieces and you see patterns, but sometimes it's fun for a while, and I'm usually hoping at some point, I don't know how long that is, but you sort of, I just hit a wall after a while.
Yeah, and do you have any like high-level strategies for how to do reverse engineering of some kind of proprietary protocol? Like what's the build, measure, learn thing where you like figure out one small thing and then test it? And I don't know, how does that typically work for you?
It totally depends on what it is. I mean, I'd say the strategy is sort of always the same. I really want to understand what are the inputs and what are the outputs, and how do I produce a specific output, by controlling some of the inputs, or where I might not have access to all of the inputs. I might only have access to one or two inputs. How can I have that traverse to the point that it produces an output that, pleases me? And I would say, I would say learn what you're, as much as you can from public information or testing or black box testing. Learn what you think is going on inside. And I'd say the best way, the nice thing is, this is software engineering radio, so people are writing software. I think one of the best things for me, or that I've found helps me compared to say other people who do a lot of reverse engineering. Some other people I've met they don't always develop software, and I sort of started with software development. I've always been sort of interested in security and hacking, but from since I was a kid, I started developing software. And because of that, I often write terrible software. And because of that, I kind of know how, certain, at least some other software developers, they might write similarly terrible software. And I can be like, if I were designing this and I were lazy, maybe I would do it this way, which would be a terrible idea, and maybe that would allow for a specific vulnerability. I should test for that. And then sometimes I'm like, well, if I weren't being lazy, if I were doing this the right way, or what I believe is the right way, then I'd probably do it this way, and this shouldn't affect this, but let's test it anyway, because you don't know who's writing it and how they're feeling that day, right? Or when they're designing it. So
fascinating. I hadn't thought about the psychology of trying to get inside the head of the either subpar hacker or that wrote the software, or the sophisticated one who was clean with their code, and how that might alter your strategy of reverse engineering.
Yeah, and often it's not even the developer's let's say fault, right? If they're writing something bad, often they have to get a product out, and I sort of understand that side of it too, where sometimes it's just about getting something out, and I think a lot of people will probably agree with that if they've worked on products before.
Of course. Do you have any long-term goals, or are you just kind of jumping from project to project, completing small things, proving things to yourself, and figuring things out? Or do you have like a macro view for where you want to go?
That's a good question. I think when I was younger, people always sort of said I need to have long-term goals, and I tried setting long-term goals, and they like never stuck around. Things always changed a ton in my life, and I think I've been really fortunate that I've gotten to experience a lot of things. So I don't have any, I guess, real legitimate long-term goals. There are specific things, right now I feel I'm really interested in doing, and right now I'm really excited about just sort of learning new things and learning new technologies, and trying to sort of create more stuff. And another thing I really love doing is sharing with other people and getting other people sort of excited about technology and about security research and creation and software development and hardware development and 3D modeling and fabricating. So I really try to put some effort into this projects I release, so that anyone else who wants to maybe jump on or get interested can also start from that or work with that and make something better. So I do definitely love sharing with other people and hopefully get some other people excited in some of these areas.
Very cool. All right. Well, Samy, I want to thank you for giving me your time. I really enjoyed talking to you. I've enjoyed the other interviews I've heard with you, and you have some very cool projects.
Oh, awesome. Thanks. Yeah, thanks for having me on.
Software Engineering Daily is having our first ever meetup in San Francisco, January 11th at Galvanize. If you live in the Bay Area and you listen to Software Engineering Daily, please come check it out. I would love to meet you. We're going to have some awesome speakers. We have Pete Hunt, who is one of the early members of the React.js team, who is now the CEO of Smite. Hasib Qureshi, who has been one of the most popular guests on Software Engineering Daily. Preeti Kasireddy, who has written about her career transition from venture capital to software engineering via Coding Bootcamp. Each one of these speakers is going to give an awesome talk, and I hope you can make it January 11th at Galvanize in San Francisco. You can sign up on meetup.com. You can also find the link on the Software Engineering Daily website, softwareengineeringdaily.com. I really hope to see you there.